Good morning and good afternoon. My name is Wheeler and I will be teaching you about ellipse. Ellipses are in the shape of an oval and are known as a conic because when you have a three-dimensional cone and you cut it diagonally, you see the shape of an ellipse. We will be learning about simple and shifted ellipse, learn their equations, learn how to graph them on XY planes, and then learn some key terms that will help us graph and identify them, like their center, vertex, co-vertex, foci, axes, and focal radii. Let's get right into it. So a conic is when a shape can be obtained by slicing a double cone with a plane, and this is seen on screen. On the far left uppermost cone is a plane cutting the cone diagonally to make the ellipse. And then of course under it, when the plane is horizontal, it makes a circle, but we are focusing on ellipse. So you can also see examples in the middle and right cones where the plane goes through the three-dimensional cone diagonally and the shape of that cut is an oval, which is also known as an ellipse. First, we are going to define an ellipse. An ellipse is a set of all points P in the plane such that the sum of the distances from P to two fixed points is a given constant. These two fixed points are called foci, or focus and focus. So P is basically the ellipse. P can be here, can be here, can be here, can be anywhere, right? And what this means is that the length from this foci to P and this foci to P, the sum of those two lengths is the same as the sum of these two lengths, or the sum of these two lengths, right? And these lengths, also known as PF1, PF2, are known as focal radii. And of course, these change, but the sum of the focal radii never change, aka the sum of these two lines, and these two lines. And the sum of the focal radii make the major axis. This axis right here versus the minor axis. So these are the major and minor axes because this is a horizontal ellipse. This is longer, so therefore it's a major ellipse, and this is minor. Lastly, when looking at the ellipse and the major and minor axes, we can point out the vertexes. The vertexes go on the ends of the major axis, and the co-vertexes go on the ends of the minor axis. Of course, if this is vertical, major, vertexes, something like that. So now we're going to move on to the equations, looking at the simple ellipse equation and the shifted ellipse equation. A simple ellipse equation represents an ellipse that is where its center is on 0, 0 of an XY coordinate plane. And then a shifted one, of course, is shifted. The center is not on the 0, 0 plane, and that is what H and K represent. They represent the shifts from 0, 0. And we will explain more of this in the examples. So normally I would start with a simple ellipse, but I have saved the equation for last, and you'll see why. So we're going to go ahead and start with a shifted ellipse. Now, as we know, the larger number is under the x value, so it is a horizontal ellipse. Next, we are going to look at the h and k. Normally, these are minus signs, right? If we go to the equation, we see minus h and minus k, so we know that h and k are really -2 and 3. And this points our center. So we go back 2 and up 3. That is our center. Then we are going to find a and b. So we're going to root each one. A equals 5 and b equals 3. And that finds us the vertexes and co-vertexes. So A, the 25, 5 under x, so we go out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then up and down 3. 1, 2, 3, 1, 2, 3. So those are our vertexes and our covertexes. And that's about how big that's where our ellipse is going to go inside. So we can go ahead and draw a box to picture that. Now we need our foci. To get our foci, we have to get the original two denominators, 25 and 9, and find the difference. 25 minus 9 equals 16. 16, and then root that. That equals 4. 4 is our foci number, so we go out 4. 1, 2, 3, 4. 1, 2, 3, 4. And now we just draw an ellipse where they'll touch at each vertex and co-vertex. You normally make it more pretty, but there we go. Now we've got the minor axis, major axis, foci, the ellipse, of course, and the center. And of course, it's a horizontal ellipse because the foci are on the major axis and the larger numbers under the x. Now we'll go on to the simple ellipse. So now I'm going to show you how you can get from an equation to a perfect ellipse so that you can use it in the real world. This is where foci will really come into play when drawing the perfect ellipse. And when you use your own graph like this one here, there is really no need for a shifted ellipse since you can put the center wherever you want. So I've come up with an ideal simple ellipse equation that we are going to graph. So first we're going to look at the equation and notice that the larger number, 81, is under the x. That means it's a horizontal ellipse. And of course the equation, the center is at the 0, 0. So now we're going to find a and b. A, the square root of 81, is 9. That means this will go 9 left and 9 right. So we can go ahead and mark that as our vertexes. We know those will be our vertexes. Then we're going to get B, square root of 12.25. That's 3.5. Then we know that's our covertexes. So here and here. Now we're going to find the foci. So we're going to take the original 81 and 12.5 or 12.25 and subtract them. That gets us 68.74. 5, I mean. Now we're going to root that to find the foci. And we get about 8.29. So we'll say 8.3. Now we're going to graph them on the x-axis because we know it's a horizontal ellipse. So 8.358. So that's about 0.3. Negative 8.3. Now we have our foci. So now what I've done is I've got a string measuring the length of the major axis. This is important because this is how big the sum of the focal radii will be. So now, if we move our push pins to the foci, and what we're going to do is we're going to slowly trace the outside of this ellipse. Now, of course, this isn't perfect because life, but we're going to keep tracing it. down here. So we can see we've messed up on the y-axis. We've gone about out further than our co-vertexes, but that's fine. We still get a pretty perfect ellipse. Now, what we're going to do is we're going to, off screen, make a seam line and then cut it out so that we can put it behind some fabric and make a pillow. So after cutting out the ellipse with the seam, I pinned it to some fabric and cut out two fabric pieces that size, and then I pinned them together inside out so that I could go and sew them with the seam being on the inside. I sewed them all the way around with leaving a little gap on the end of the ellipse so that I could turn it inside out and then stuff it and then just hand sew the rest. So this is my finished product. It is the Ellipse pillow. Sewed it all the way around and then finished it up there by hand sewing. And I'd say it came out pretty good for being one of my first times sewing. Thanks, Mr. Kilroy, for a great year. And if there are any students watching, I hope this gives you some creativity to use your math skills outside of the classroom, because this was pretty fun, I have to say. Thank you.